Good afternoon, everyone. This is Pranav from DFI India office. I welcome to I welcome you all to DFI India Groundwork Webinar 5. This webinar is sponsored by Piletest. We thank the webinar sponsor. We'll quickly watch the video from DFI India before moving forward.
I come because I like to learn about what is going on in the industry. I like to hear from the contractors, especially because being an engineer, sometimes it's good to learn from the contractors what innovations they're coming up with, and obviously to meet with other folks and see what they're working on.
This conference is probably the most important event during the calendar year, so you cannot miss it. Because here you can meet a lot of people, contractor, supplier, competitors. So as I said, it's the most important event in the calendar for foundation business, and it's too important to don't be here, let's say.
We come because we get a lot of exposure to people who use our equipment. Camaraderie, a lot of camaraderie. Even with our competitors, we come out and we rub shoulders. Everybody knows everybody. It's just one big happy family.
Well, it depends on whether or not you want to continue learning. If you got a desire to continue to learn, then you need to be at DFI.
The good thing about this conference, you can meet a lot of people over and over, so you can make a very good connection with the industrial people.
Networking's huge. There's so many people here, just from different parts of the country and the state and the world even, and just seeing what processes they're using and their design methods and their equipment, and just really a lot of exposure, and also getting connected with those people for potentially future work, future jobs.
Come join us. If you're interested in anything in this industry, this is the place to be. This is it.
Yeah, welcome you all again to this Groundwork 2022 Webinar 5. So before starting the webinar, I'll quickly take you through a few of the instructions. Recording of this webinar is prohibited. Participation certificates will issue in 2 weeks' time. An online webinar recording will be available on DFI of India YouTube channel in approximately 2 weeks' time. You can visit our YouTube channel anytime. You will see the previous webinars also, and plus this one also. So anytime during the program, you can ask your question using this Q&A tab. Put your question and send it to us. After the presentation, during Q&A session, the presenter will try to take these questions and answer your queries. So now it is time for me to introduce the webinar moderator, Dr. Sunil S. Basarkar. So most of you already know him. He is General Manager and Head of Geotechnical Engineering Department at Afcons Infrastructure Limited, Mumbai. So Dr. Basarkar has a total experience of 18 years in field and 16 years association with academia in the area of geotechnical engineering. Dr. Basarkar has published more than 50 papers in various national and international conferences and reputed journals. He is a core committee member of DFI of India, and he is also a fellow of Institute of Engineers India, IGS, Institute of Bridge Engineering, and Dr. Basarkar also serves as an editor of DFI India, DFI Journal, USA. So I welcome you, Dr. Sunil Basarkar, to moderate this session, and I kindly request you to take the session forward.
Thank you very much, Pranav. At the outset, I thank the DFI of India for giving this opportunity to moderate this session in presence of eminent speakers for today's session. This topic is a burning topic, and I'm happy to convey that we have a wide spectrum of the interested participants. They hail from 23 countries and that speaks of volumes about the initiative that DFI of India is taking in form of ground work. So I welcome all the audience, August audience, and I welcome also the eminent speakers who will be making presentation on the diaphragm wall. Over here, we have a program that are lined up for today's session. The presentation is by Mr. Erez Amir on the topic, why you should measure the inclination of your diaphragm wall. This will be followed by a question and answer session, and each of the audience are requested to put up their questions, if any, in the chat box as the presentation progresses. There'll be a closing remarks from my side as well as from the organizers, if at all, and then the details of the upcoming program that will be announced by the organizers. I'll request for the next slide, please. Well, to introduce you to the eminent speaker, Mr. Erez Amir, he is president and founder of Piletest.com Limited. Mr. Amir is a software engineer and is a president and founder of the Piletest, a family-owned company focused solely on the development and offering a non-destructive testing systems for the deep foundations across the globe. They have a product such as the CHUM and the PET, which are widely used in the analysis and actual fault findings in the pilings and the deep foundations. After graduating from Tel Aviv University, Erez was recruited by Microsoft, where he participated in the development of the Windows XP and 2000. Later on, he formed a Piletest together with his father, Dr. Joram Amir. Let me convey and share with audience that Joram Amir, like his son, is an eminent contributor to the foundation industry, and many of his books are well authored and have a lot of acclaim in the global arena. Erez's responsibility in the Piletest, in addition to the daily operations, are software development, starting from the microcontrollers to the full-scale application. Erez takes pride in developing the tight, intuitive, user-oriented interfaces. So without taking much of the time, I'll now request Mr. Erez Amir to share his valuable experience with the audience, which are very keen to know about the diaphragm wall. Mr. Erez, please. Thank you. Your mic is on mute, Mr. Erez. You can unmute your mic.
Yeah. Okay. Thank you very much, Dr. Sunil, our moderator. I will start our presentation with no delay. Yeah. Okay. So, as mentioned before, the topic of this presentation is measuring the inclination of a foundation wall. Please do take notes during the presentation. Most slides will have a slide number on the bottom, which you can take a number that will really help me find the relevant slide in your question. Otherwise, just use free text to write down your questions. Let's start with a broader definition of what pile integrity is. So in general, pile integrity is complying with the design specification regarding two things. One is the pile material, the other is the pile geometry. And if this sounds vague, I have example for both. So when we're talking about a material, we're talking about reduced concrete quality. It can be a void or a soil inclusion, mixed soil or slurry with concrete, or anything that reduces the concrete quality, as well as segregation, honeycombing, etc. Another example for that is a soft bottom, especially important when we talk about end-bearing piles. In this case, when you have a loose material in the bottom, of course, when the pile was not clean or a collapse happened just before pouring, that's a soft bottom and a flowed material at the bottom, which affects the designed specification. Another example for abnormal geometry is, of course, general and the most common and the first thing that you think about when you talk about pile integrity is a shorter pile. Another example is a necking, and one that is not displayed is, of course, the opposite of that, bulging. Bulging can also be a severe problem when you have negative friction, which we're not going to get into right now. But necking is definitely a very common issue with pile. And now we reach the subject of our presentation, which is inclined pile. Now, inclined piles are not intuitively considered a pile integrity issue, but let me show you in this presentation how much this perception is wrong. But first, let's start with some examples. So this is a classic example of a flowed pile with a huge soil inclusion. The soil was washed out by high pressure water jets just to expose the dimensions of the defect. And of course, this pile could have been repaired at this stage. Had it not been tested and the problem would not have been repaired, this could have ended up very badly for the owner and the public using that building on top. Let's get to the subject of inclined piles. So we've run a finite element simulation on a pile with an inclined pile with a 3,000 kilonewton load. And we see here the load distribution, the bending moment distribution. And we can see that the top of the pile gets a very high bending moments. Very often this can be much more than what the concrete is designed for. And this is unexpected. I mean, this is never planned for. The design of the pile does not take that into consideration. All the design is being done on a totally vertical pile, and this kind of inclination can introduce totally unexpected forces and, of course, potential problems to the pile. So that's really one aspect of why inclination can really cause severe, sometimes catastrophic issues into the pile, but it's definitely something that we should consider in our design. The other issue with inclined foundations, or not just piles, but walls, is the design of the underground parking garage, which is very often in the case in many buildings. Now, there is a standard number of parkings that has to be offered in a specific building per size. It depends from place to place, but usually the design is not very generous on the parking. And if a specific number of parking slots is required, there will be very little or no spare parking spots available. Now, if the walls supporting the building are inclined inside, it is quite possible that some parking spaces will not be available. It can be that bad. Or it can change the parking from, a moderate normal car to just a very small car. this can cause a severe problem to the dealing with the authorities regarding the permits of this building, because not all the designed parking spots which were designed and the building got the permits for will be available. In addition, it's a loss of a very sometimes very expensive area to the building, to the underground garage, as well as other problems. But that's not all. Let's talk. Let's see some example. This is this is maybe the most extreme problem that I could find with a retaining wall, and you can see that what you see on top is really not what you get when you actually excavate and look at the size of the pile. You can see that in this project, almost all piles are flowed in one way or another. It can be bulging, it can be inclination, it can be the joint between the piles, etc. And here's another example of an underground garage with barracks, with load carrying walls. And you can see that here and here and here, if you can follow the cursor, some of the walls, panels are really inclined inwards. And this inclination can be quite significant in many cases. So as I told you in previous slides, this inclination can affect the parking spots, but it also has another very severe problem, which is going to be seen next, and this is water tightness. More common than not, foundation walls are also protecting the underground garage from the groundwater. And when these groundwater start seeping or penetrating into the excavation, this can cause a very severe problem, as can be seen in this video right now.
A Sky 10 view today over the excavation site for Miami's so-called deepest underground parking garage in Miami's Brickell neighborhood shows a pooling of water in a different area from where water bubbled to the surface on Friday in a second breach. That happened.
So as you can see, this breaching can be a very hard problem to fix. Sometimes it's very hard to stop a breaching once it started, and it will only stop once the water level has reached the final groundwater level. In Germany, the National Library in Köln, I think, suffered a severe damage because of a nearby excavation. The water penetration pulled out the sand from underneath this historical monument and caused very bad damages to the building that could not have been repaired later on. And in other cases, this was also resulting in loss of life. So water penetration, besides being dangerous, is also very costly and something that definitely we want to avoid. Okay, I have here geodetic measurements of a contiguous pile wall, which we can look at the offsets of this pile wall, which is depicted here in the black line versus the red line, which is the design. So this is actually the top of the wall at plus 24 meters. And at this level, there was already a small deviation of 265 millimeters from the plant, from the red line. But as we go farther down, when we go to 21 meters, this deviation already increased to 0.4 meter, 329 millimeters. And a small deviation also developed on the top part of the wall. And as we go farther, we can say that this deviation was much larger, half a meter already. And at the bottom, this increased even more, and a 60 centimeter deviation, 569, can be a real problem to the underground parking garage, especially in tight spaces and where area is expensive. Also, if you will calculate the loss of area, you will find out that this is quite an expensive failure. And that's another level here. And of course, it just gets more and more severe. I think this is the bottom. Now, so what do the standards? What are the typical requirements for cases like that? So let's first start with the easier case, which is piles. So in the Federal Highway Administration requirements, which are also very common to many other countries and places, require 1.5% of piles in soft soils to 2% when the piles are in rock. That's a very typical requirement. But we will see that this requirement applies to piles. But when we talk about walls from all types, this requirement might not be strong enough. And of course, the standard has took note of that, and we will get to that in a few slides. So the first case we will discuss is secant pile walls. And I will give a very short introduction because I'm sure most of you are familiar with what secant pile walls are. But these walls are being constructed in two phases. In the first phase, the primary piles, which are pile number 2 and number 4 here out of 5, the primary piles are being dug and filled with concrete with no reinforcement. I repeat, there is no cage, no reinforcement in the primary piles. When the concrete just starts curing, which means it is not liquid, but it is still relatively soft, but it can stand by itself, the secondary piles number 1, 3, and 5 are being drilled through the primary piles. So it takes a little bit of section from the piles, and in theory, this method should give us a very good joint between the primary and secondary piles, and this should ensure water tightness. Of course, the secondary piles are already equipped with either rebars or I-beams or something similar. But in any way, this method, which looks really nice on the surface top view, can potentially fail miserably if the piles are inclined. If you will look at it, if the inclination would be just at the bottom, will be just about 1 radius, the water tightness will already not be kept, and water will be able to seep from outside in between the piles. So to ensure that this does not happen, secant piles should be measured. The deviation or inclination of the secant piles of each wall must be measured. The standard has really taken care of that, and when we talk about walls that should be tight, the allowable tolerance is 1 to 200 or 0.5%. In comparison, for normal piles, it was 1.5 to 2%. This standard, by the way, is a UK standard, a UK code. So, okay, so how do we measure the inclination? In the old days, inclination was measured by a very simple, very reliable method, just inserting a straight beam into the foundation and using a level either on the beam itself when it's a vertical pile, or using a plumb to measure the inclination and hence the deviation. This was in the 1950s, and we have done a bit of a progress ever since. Nowadays, there are a few types of measurements. One of the most advanced measurements is measuring during the excavation. Many augers and drilling machines, etc., have a built-in sensors either on the excavator itself or on the cables that can measure the inclination and deviation at any depth, and they will output a chart just like that, so you can see the deviation at any point. In this case, this is a 63 and some meter deep wall with a maximum deviation of about 0.4 meters. And that's not too bad, but still, this could sometimes cause problems. The next class of measuring devices are what we called pendulum-based systems. These are systems that are measuring after the excavation is finished. The first and very well-known system is the Coden system. It is very well known because I think it's the oldest in the market. This system was originated from Japan. The principle here is to lower a sensor into the wall, into the shaft, which must be filled with a slurry. And this sensor in both systems here, the sensor is equipped with ultrasonic range meters, actually, that measure the distance to the shaft walls at any elevation in several directions. In the Coden, it's just 4 points every 90 degrees. In the sonic caliper, it's a rotating sensor that measures in many more directions, but the principle is the same. What the main purpose of these systems is actually not to measure inclination, but to profile the pile, to give some measure of the shaft volume. Contractors are sometimes very much interested in the actual volume of the shaft because they need to order an adequate quantity of concrete. They don't want to order too much, and they definitely don't want to order too little. So these measurements can be a real lifesaver for contractors. As a side product, these measurements also measure the inclination of the pile up to a certain degree. Let's talk about the pros and the cons of the pendulum-based systems. So the biggest advantage is, of course, that these methods map the excavated profile. So as I told you, you can tell the volume and diameter and shape at any elevation. The drawbacks are that these systems are quite bulky. They require a crane to move around. They are very slow to operate. These methods are also limited just to open boreholes with slurry. You cannot test dry holes, and you cannot test finished piles. But the biggest drawback is that these methods are limited to inclinations smaller than radius over length, R over L. When the inclination becomes larger than R over L, and this is a totally possible case in very slender piles, then the sensor will just touch the inclined pile wall, and from that point onwards, it just drags downwards on the pile wall and will not measure the inclination anymore, or will not actually give a profile. In addition, these methods are also limited to a certain diameter, after which the distance becomes too large for the sensors to pick up. We will now talk about the other class of measuring devices.
There's a loss of sound.
No, sound is there. It is fine.
Yeah.
Okay.
Can you hear me? Yeah. Mr. Moderator, am I heard well?
Yes, it is fine.
Okay, so let's us continue. The next class of inclination testing is inclinometer-based systems. And here I'm introducing the BIT, borehole inclination tester. The system is actually a digital inclinometer in a sensor, also equipped with a gyro to compensate rotation. And it can be lowered on either a centralizer, a small centralizer, just like very common inclinometers, and that can be inserted into a small tube, a very small diameter tubes. And this method can also be used by installing the sensor on the bucket itself as the centralizer, as can be seen here. So in open boreholes, the BIT, the BIT sensor, is installed on the bucket itself. The bucket behaves or serves as the centralizer for the excavation, and the inclination at any point is being measured. Once the inclination at any level is measured, the results are displayed in either a top view showing the inclination at any point, or as a side view offsets that you can see here that there is an inclination of 20 centimeters. This is also displayed here on the text result. Maximum offset 20 centimeters and in percentage towards a certain direction, north, northwest. The diagonal lines seen here is the permitted offset in this case, which can of course be inserted by the user. So try to imagine the permitted offset as a virtual cone penetrating the ground in, let's say 2% if this is the standard, and the pile axis should remain inside that permitted cone, and any penetration outside of that cone is considered an integrity issue that should be addressed. Next, I'm going to show you a short video about how actually testing the wall verticality is being performed. It's a 3 minutes video, all animated, so you can see also what's happening underground, etc.
The square pier is surrounded by diaphragm walls. The wall elements were cast with access tubes for cross-hole ultrasonic testing. The walls are 30 meters deep. Are they vertical? The bit sensor and centralizer are lowered into one of the tubes. The bit is lowered to the first stop at 5 meters. With the stop sign switched off, the bit is lowered to the next stop. The procedure is repeated all the way to the bottom. The The bit is now raised, stopping at the same stations. The bit is now at the surface for final reading. The top view is now seen on the screen.
The side view is plotted on the screen in the desired direction.
The deviation of bored piles is measured the same way. The verticality of secant pile walls is of utmost importance. The bit can also test simple low-cost tubes for geophysical testing. Thank you for watching.
Okay, thank you for watching that. So let's talk a little bit about the pros and the cons of this measurement method, the inclinometer-based method for testing verticality, the bit. So the biggest drawback, of course, is that this method does not measure the pile profile. You have no idea if there is a caving at a certain point or a enlargement, anything. There's just no information about the profile of the pile. The information that you get is about the verticality or the offsets, the deviation of the pile or the shaft axis at every point. Now, as I said before, profile is typically more interesting to contractors, while axis deviation is more interesting to the specification and to the designing engineer, for the reasons I specified in previous slides. The more advantages of this method, it's very light and portable. It's one-man operation. A single operator can carry the system in one hand. It's a very modular system that can be used for all sizes of holes, starting from a 5-centimeter tube to the largest piles of any size. It can be used on any type of pile. It can be driven, even sheet piles, if a suitable access tube is being welded. It can be used on wet holes and dry holes, doesn't matter. And it can also be used on wrecked piles. The method is compliant to the ASTM standards D8232, which we are a very proud members of the committee who wrote the standard. In fact, we were the main technical contact. We drafted the standard, and we, of course, with the help of all committee members, it's a shared effort. Here is just the first top of the first page of the standard. Of course, I cannot show here the whole standard. ASTM is based on purchasing the standards, and they cannot be distributed free. But there is, and this is the ASTM standard test procedure for measuring the inclination of deep foundations with all typical methods, both pendulum-based and inclination-based methods. I'm going to talk a little bit about how borehole verticality is going to be measured, is being measured with the inclinometer-based system. This is important also for secant walls, where you would prefer to measure the verticality of both primary and secondary piles before pouring. So let's go on. This is also about a 3 minutes video.
BIT, Borehole Inclination Tester. Test an inclination of boreholes using the auger bucket as centralizer. The borehole is stable, but is it vertical? This is the BIT, Borehole Inclination Tester. Start by passing the cable around the wireless depth meter. Then, mount the BIT probe on the bucket and set it to 0 at ground level. After stabilization, lower the bucket to the first measurement stop. The software takes a measurement automatically at each stop. Raise the bucket back to surface, while stopping at the same stops on the way up. Finalize the test to get the overall deviation picture. Top view representation of the whole deviation. Side view representation of the whole deviation.
Okay, this part of the video is very similar to the previous one, so I'm going to stop it at this point. The purpose that the reason I showed you this video is just to show that this method is modular and it can test holes both before pouring and after pouring using the access tubes, the same access tubes used for cross-hole sonic logging if this being done. So this actually is like a Swiss Army knife covering all the requirements for inclination in the case of foundation wall elements, either secant walls or barrettes or individual piles of any size, both after pouring or before pouring on open shafts. Thank you very much for watching. I'm going to stop sharing now, and I will now move the torch to our moderator.
Thank you very much.
Yeah.
Definitely, this was a highly informative session, and more often focused on the burning issues of the inclination problems. In fact, in India, we had been involved with a lot of retaining works, and particularly in metros, which is a global phenomenon where secant piles, the contiguous piles, the diaphragm walls, they are very popular in India. And particularly in high water table locations, any inclination of, let us say, the secant pile, it is bound to prove very harmful for the seepage conditions. If the secant piles become inclined more than the permitted or the threshold values, there can be a problem of the seepage, and that adds to the value of the contract. As rightly conveyed by Erez, the problems of the alignment. Alignment problems can lead to fouling of the available working area, the built-up area. If your peripheral walls, they are inclined inwards into the excavation site, naturally there is a threat that your built-up area is going to be disturbed. And not just a technical problem, but it also involves a contractual and a payment problems. So then a diaphragm wall, when we speak, they are constructed in panels. If each panels they are inclined more than the desirable value, there can be a problem of trespassing. There can be a problem of, again, a seepage. My own experiences, they have indicated that there can be a problem of breaking of the rubber stoppers at the joint locations. And of course, the seepage and the fouling problems are always associated with inclination. Whereas I compliment on giving us a very important slide at page number 20 of your presentation. That is the oldest method of measuring the inclination. How we could introduce the scale into the bore and then raise it up and then measure the angle in a very, very manual, but yet a very, very convincing way. We have a couple of questions. I draw your attention to the chat box.
Sir, before moving to Q&A session, we'll just play a short video from our sponsors at Piletest, and then we can take the questions. By that time, audience can type their questions and send more questions.
Should I continue with the question, or you are going to put up the video?
We'll play a short video and then we'll continue with the Q&A session.
Fine, carry on.
So we thank our sponsors for this webinar, Piletest, and now we'll start with the Q&A session. Sunil sir, please carry on.
Yeah, thank you, Pranav. I had introduced you to the problems of the inclination earlier. I take on to the chat box. I draw attention of areas to the chat box. The first question comes from Mr. Anirudhan. It asks how much time it takes to measure a pile of 1.2 meter diameter and 30 meter depth using a coding. You're on a mute.
Yeah, always forget the mute. Yeah, well, thank you very much, Arinduhan, for this question. In fact, we are not very familiar with the Coden, but I've seen people using it, and it takes a very long time for the actual lowering and then raising of the cables. The cable must go into a very fine slotted drums, and I think it takes a few seconds per meter. So this will be one of the biggest time elements. The other thing is that there is an overhead time of just getting a crane and moving the cordon on top of the pile and arranging that. So I would say that in total, you should be within approximately 1 hour of testing for a 30-meter pile, and I might be a little bit optimistic. When you are, on the other hand, talking about inclinometer-based systems, then this time will typically be 10 to 15 minutes. There's a very little overhead time there. Can I move to the second question? Or would you like to read it? Yeah.
The second question is my own concern. Continuous monitoring, we get it from the rig unit, the computer unit. Is there any other way where we can monitor continuously the inclination without stopping the boring operations?
Well, yes, there are some systems like that I've seen in the market. They require heavy instrumentation of the auger, of the drilling machine. Your other alternative is using the bit because the overhead time is very small. If, for example, you can start measuring after you have done 10 meters, take corrective measures, realign the rig, etc. Then measure again after every 10 meters. It's just a 10 to 15 meters delay, and you can take corrective measures while actually excavating. So true, it is not totally true real time, but it's real enough time. I can also tell you that when a system is using the instrumented auger, it is something that is operated by the contractor. And the owner is usually, there's a trust issue sometimes, I must say. And the contractor it's very welcome that the contractor will measure their own work, but the owner is usually interested in the results of an independent laboratory who does not depend on an instrumented rig. Next question.
Yeah, I agree with you. I take the next question that it comes from Shiva Subramaniam. He asked what consideration we need to take for installation of inclinometer.
Oh, okay. Thank you very much, Mr. Shiva. Well, that depends. Of course, the diameter of the shaft or the access tube is of the utmost important, and you need to prepare to that in advance. Up to small diameters, let's say 0.3 or even 0.5 meters, a mechanical centralizer can be used for the inclinometer-based system. After that, it becomes too bulky, and in a larger diameters, actually unlimited diameters, the auger itself, the bucket of the auger is being used as the centralizer. It is a centralizer because the bucket is what actually dug the hole. So it should fit quite nicely inside and gives relatively good results. Sometimes not as good as a mechanical centralizer, but definitely good enough to meet the standards.
Nice. I take next question from Mr. Bimal Chandra Roy. He says that we have seen some method of measuring inclination, but in case of a precast pile, let us say driven pile, or even CFF pile, how we can measure the inclination?
Okay, in both these cases, the inclination-based system must use an axis tube. The same axis tube that is very often used in cross-hole sonic logging. And this axis tube in a CFA pile must be welded to the cage. Hopefully the cage is lowered to the bottom, or just the tube itself can be lowered to the bottom. And in drilling piles, there is very often an internal central hole in the concrete pile that can be used for jetting. So this hole itself can also be used very accurately for measuring the inclination.
Any instances where this central jetting hole had been damaged and we could not insert the inclination?
Yeah, this can happen, of course, yes.
This can happen, right. I take the next question from Haryana Verma Barik. So can inclination of 100 or 150 mm borehole inclination be measured through your equipment? I don't know what this measurement is.
Yeah, it's a small diameter holes or actually tubes. It can be water tubes or yes, absolutely yes. And this is a very common case. This has been done for thousands of holes, and we have a very good experience in that. There's a very good and good fit centralizer for these diameter holes. It's very good in the sense that you can get a very reliable measurements with a very small accumulated error. Yes, next question. Sorry, the line was interrupted.
Okay. Yeah. Mr. Ratnesh Kumar, he asked, what is the alternative other than the coding test in metros? I'll give you the background because most of our metro projects, they make it coding testing mandatory. So is there...
I'm sorry.
You can take the question, Mr. Harris. I think there is some network issue at Sunil sir's end. You can take the question.
Alternatives to...
I'm sorry, the line is not very good. Yeah, I didn't hear your explanation about the problem or but I can read the question. What is the alternative of coding in metros? Well, if the specification calls for a coding test, which is a trademark, then there's very little that can be done. But if the specifications call for testing the inclination, then the beat system that we offer is a perfectly valid alternative.
Sure, you can take the next question.
Yeah. Can the oh, sorry. The next question from Arnia Brahma Barik. Can the set equipment measure the inclination of offshore hollow piles? Yes, as long as there is an access to the top of the hollow piles. Yes, sometimes if the hollow piles are with a closed tip, then the soil will enter this hollow pile and this will block the measurements, but you can definitely measure up to that level. Since these are quite rigid tubes, quite sturdy metal, then you can definitely extrapolate from that point onwards. Okay, the next question is quite long, so let me first read it. Yeah, so yeah, usually piling diaphragm wall job sites have a crawler crane on hand. Coding is used more often than any other device. Time to measure a pile with move in and out is about 40 minutes. It can be used to profile and give the length R and USDS inclination of piles off the diagonal walls panels. Moreover, they give you the profile. They are set on any collapse of ballage, and therefore a concrete volume required. Being an ultrasonic sensor with the emitter and recorder and the same probe, it can therefore also be used in dry holes. The problem often incurs with the coding is the cleanness of the bentonite or the polymer mud. Any solid material in a suspension block will block the wave and result in fuzzy readings. Yeah, well, I'll try to answer that. The reason the coding is used more than any other method is because this is the oldest method in the market, and no alternative methods have been available until we came up with the bit. It is true that the coding can measure the profile of the hole, and 40 minutes was about very close to my estimate. Of course, it depends on the length. So yeah, I'm not saying that the coding is a method that should not be used. Definitely not. It's a good method. I'm not into mudslinging at all. I'm just introducing another alternative to measuring the inclination, which is not at all sensitive to any cleanness of bentonite or polymer, or even the existence of such. As I said, we see that as a Swiss Army knife for inclination measurement. It can measure in all conditions, and it's an alternative to the codon, which might be considered. And there's also, of course, the question of availability and operation. We're not going to get into prices too. Sivananda, there might be a chance that inclination of access tubes will be more the inclination of the pile based on the placement of access tubes. How can you make sure that both are the same? This is very true. And sometimes the inclination of the access tubes will be different. However, there is more than one access tube in the pile, and you can measure 2, 3, or even all of them, and average the results to get a good estimate of the pile. Also remember that the access tubes cannot deviate more than that much into outside of the or into the cage. And in addition, when the design calls for inclination testing using those tubes, special care should be done in the workmanship of these tubes to make sure that they are actually parallel and vertical and straight, and this will minimize the problem. Okay, Ratnesh Kumar asked, why can't we use the codon for dry holes? Well, frankly, thank you for asking that. I was not really aware that the codon also works very well in dry holes. There is a distance meter, ultrasonic distance meters, and it can be probably used in these cases. Do we have the time for one more question here?
Sure, you can take the last question.
Pranav, I'll request you to take that question because that screen is not visible from my side.
Oh yeah, I'm reading it. Up to the plugging the offshore piles, can only the inclination can be measured? Is that right? Yes, of course. If there is a plugging, then there is no instrumentation that can measure the inclination of anything below the level of the plugging. The inclination above the plugging can be measured, and as I said before, because those piles are very rigid, then some extrapolation of the hole, of the inclination of the hole, can be safely assumed below that level. Okay, one last question from
please proceed.
Yes. Practically, what is the permissible inclination limit? If it is exceeded, how can we overcome that? Thank you. So the permissible inclination is up to your local standards, but it should be in the design and the specification of the project like any other specification. And it's typically 1.5 or 2%, depends on the conditions. Now, sometimes there is very little you can do to repair actually the inclination of an existing borehole, but information is gold in this case. When you know that there is an inclination in advance, you can take preemptive measures, for example, to seal the joints from the outside by additional excavation. So actually make an additional outside excavation just to seal and add another layer of concrete just to make sure that there will be no water seepage. By the way, the word seepage is misleading. This can be a high pressure jets of water depending on how far you are below groundwater water. But if you are 10 meters below groundwater level and you reach a seepage or a leak, this is already 1 atmosphere of water. That's quite a strong water jet. And this will wash out all the sand in the way. And up to you about timing.
There's a last opinion that has come from Stephen Steny. Coding testing should be proposed for the first few panels and the piles. If the repeatedly of the quality work is proven, then the coding can become a quality assurance device. So that's a good opinion, suggestion, and based on his varied experience, he has put up this matter. I think I will take a call to end the session with information to all the audience that any unanswered question that will be taken up in an email separately to all of you. And with this interesting question answer sessions, including some of the valuable suggestions and opinion, I would like to conclude this session with a big thanks to the eminent speaker of today's groundwork session, Mr. Erez Emir. He had been he has shared his valuable experience, and he has been into a very, very refined part of the deep foundations, namely how to control and how to measure the inclination. So what he has said, interestingly, not just to measure the inclination, but there are also ways and means to control the inclination of these supporting structures. So thanks a lot to the organizer. Thanks a lot to the eminent speaker, Mr. Erez and Mr. Gadi Lahad, for a very valuable presentation to our audience. With this, I pass on this session to the organizers of the DFI groundwork program. Thanks a lot.
Thank you so much, Dr. Erez, Mr. Gadi, and Dr. Sunil Basarkar. Thank you so much for this program, and especially thank the sponsors of this program, Piletest. So now I again thank all the individuals involved, all the audience member, to the presenter. Thank you so much. And before closing the session, I'll give few details about this groundwork program. So we'll be stopping this groundwork webinar series for a few months now, and we'll start it after our annual conference, which is scheduled in September. So after like probably October or November, we'll again start this groundwork 2022 webinar series. So we thank all of you for joining all these webinars. And now coming to DFI India 2022 annual conference. So this is our flagship conference. This is the 11th installment. As many of you already know, it is planned in Tirupati between September 15 to 17. So the venue is Fortune Select Grand Ridge Hotel in Tirupati. Conference chairs Professor A. Murli Krishna from IIT Tirupati and Engineer Anirudhan IV from Geotechnical Solutions Chennai. sponsorship and exhibition bookings are open now. We have already got our title sponsor. A big thanks to Keller India team for sponsoring. We have exhibition facility also, and after 2 years we are having a physical program, so that adds to the excitement. So I welcome all of you to join this conference. The themes you can see: deep foundation, deep excavation, innovative techniques and testing for geotechnical investigation, monitoring QA/QC, challenges to working and impact of existing codes, ground improvement techniques and mast stabilization, geotechniques for marine, nearshore, coastal construction, research experiment, numerical methods for deep foundation and deep excavation, monopile and other advanced deep foundation testing system, and deep foundation in coralline and carbonate rocks, and any other topic. So all these topics will get covered during the DFI India 2022 11th annual conference. I wish to see you all during this conference in Tirupati. For any more information, you can always visit our conference website that is displayed here. We'll soon send our brochures to you all. And I again thank all of you for attending this conference. I thank the speakers. I thank the moderator for a wonderful job. I thank you all.
Thank you very much. I really want to thank you, Pranav, and Dr. Sunil for organizing this and for giving me the chance to put this presentation. I especially want to thank the audience for taking the time to listen to my presentation and to put up this excellent list of questions, which by reading it, I can see that you were actually listening. So thank you very much, and I hope to be privileged to present to you in the future.
Thank you very much. Thank you. Thank you so much. Thank you, Mr. Kadi. Thank you, Sunil sir.